flexibility method. It is a quick revision of whatever we did previously, and it will be followed by solution of two other problems. And then we will stop this flexibility method and will start the stiffness method. The truss shown was having 6 members. It was having 3 supports. At A, we were having the hinge support, at B, roller support, at D, roller support. So what we did, we found the external indeterminacy by R minus 3. 4 were reactions, 3 were available equation, and it came out 1 degree external indeterminate. Internal indeterminacy we found by M plus 3 minus 2J, it was 1 degree. Total indeterminacy was 1 plus 1, so it was 2 degrees. So we declared this 2 degrees total statically indeterminate structure. One was external, and out of that one was internal. Now, our next slide, what we did, we selected one support reaction which one, and then member force AD, which is tensile in nature, AR2. And here you can see AR1, AR2 declared as unknowns. Corresponding displacements to AR1, AR2, those were 0, so we recorded them equal to 0. And just for resolution of the diagonals into the rectangular components, we found sine theta and cos theta also. Next, we showed the primary structure. So here you can see at D, the AR1 is removed, and from member AD, the redundant action AR2 is also removed. And we are showing now only the released structure. After this, we went now and we started step number 2. Step number 2 was about the calculation of the capital PI values and the small u1 and u2I values depending on the statical indeterminacy of the problem. How PI were calculated? In PI, the basic determinate structure was subjected to the actual applied loads. At joint C, 10 kept to the right and 20 kept downward, those forces were applied. So now we analyzed this structure. It was a determinate structure. We found all the member forces and all the support reactions. You can see it. We found first the support reactions, and from there we analyzed this for the member forces. So we took joint A, B, and D and analyzed all the member forces. And here you can see now the analyzed structure under the actual loads. And from here we will be picking the capital P values. This will give the P values. It is showing you the nature of the force and the magnitude of the force in each member. Cut member will be having 0 force. Then after this, the same release structure we exposed to the AR1 unit value. Here you can see at D in the same direction, 1 kip is applied and this structure is analyzed. So first we find again the support reactions, and from there then we go joint by joint and find out the member forces. So here these are the various joints taken, and here now we have the analyzed structure as the redundant action was applied corresponding to AR1. So this will be giving you U1 in all members. I is for the member. So U1 values are calculated. Then corresponding to AR2 unit action is applied. So here you can see the same now basic determinant structure exposed to the AR2 is equal to 1, and the structure is analyzed. Now again, each joint you can see all the member forces are found, and they are now each member is labeled with their appropriate direction and magnitude. So U2 values are generated. Now, next, we go and complete this table. This is member forces table. So all the members you can see A, B, C, D, E, F, A, EA values you can see in the next column. Then lengths you can see for each member. Capital P values already we found, U1 values already we found, and U2 value already we found. Now, our DRL1 will be combination of this P and U1 value, the product, and then summation of all these members divided by L multiplied by L divided by AE. So from these first columns, you can complete your DRL1 value. Then DRL2 will be PI and U2I, this combination. Then F11 will be coming from the product of U1 to U1. F22 will be coming from U2 and U2. And F12 is equal to F21 will be U1 and U2. Here you can see all these, from all the six members, you can see the combination now. DRL1 was PU1LI divided by EA. So when we do this for all the members, we get DRL1 value. Similarly, DRL2, it is PIU2ILI divided by EI. So we can see this, calculate this value for DRL2. F11, as I said, it will be U1I square. So here you can see that from all the six members, the contribution, and it is coming 87.5 divided by EA. Then F12 and F22, those are calculated. And finally, we apply now once this F matrix is calculated. So finally, now we have step 6, where the compatibility equation is applied. Compatibility condition. From compatibility condition, we find the value of AR1, and that AR1 value is calculated here. So AR1 is coming minus 5.14, and AR2 is equal to 0. Now we put those numbers now on the sketch, and to calculate now all the member forces, the member force now here will be coming AM, and it will be again equal to AML plus AMR times AR. So here this equation we see all the member forces for AML and AMR, those are calculated. So we put them in this equation, and here you can see how the AML is calculated. AML was when it was analyzed under the actual nodes for each member. You see for all the six members, those AMLs are given. First column was coming from this situation where it was under AR1, unit AR1 value. So this will give you the first column of AMR. Then the second column will be generated from here where AD was exposed to the unit action here. This one second column was, and this is how the AMR matrix is generated. Now in this equation, we put all the values and we solve it, and all the member forces are known now. We see all the member forces, and then we put them on the final sketch. We label each member with their force and direction. So here, this is now the completely analyzed structure. You need to find out the support reactions also by using the same concept I asked you. Now here I'll stop now, and if you have any question, you can ask me. Is there any question, any clarification you need? If I am hearing such a long pause, so it means there is no question. So I'll go to problem number 2 now. Let's start problem number 2. Now you should be quickly making a sketch of this on your pages. एक notebook पे इसका जल्दी से आप sketch बना ले. Analyze the given truss using flexibility method. Horizontal at the bottom we have three spans, each 40 feet, 40 feet and 40 feet. At the top in the middle you can see the same 40 feet, the height of this truss 30 feet. And you can see there are three diagonals, two verticals. At the bottom card we have three cards and at the top we have one card. At F and E location, at F and E we have vertical 20 kip loads applied. At A we have hinge support and at D we have a roller support. At C also we have a roller support and at B also we have a roller support. So if we look at how many reactions we got, 2 at A, then B, C and D each we have one vertical reaction. So we have 5 reactions, 3 available equations. So 5 minus 3, it is 2 degrees externally indeterminate. Internally, what is the situation? We have 9 members and we have 6 giants. So M plus 3 minus 2J, it is giving us 0. 12 minus 12 is equal to 0. So internally, it is determinate. Total indeterminacy is 2 plus 0. So it is 2 degrees. Means the total indeterminacy is 2 degrees. So statical indeterminacy is 2 degrees, external it is 2 degrees, internal it is 0. It means in order to make this structure a release structure or basic determinant structure, we need to remove 2 support reactions. We don't need to cut any member. Why? Because it is internally determinate. Okay, so you try it quickly. Okay, so now we go there and look. Intentionally, I'm assuming now AR1 and AR2 in the downward direction, let's say. That these are my unknown support reactions. And here maybe I'm looking stupid now. 20 and 20 kips, they are acting in the downward direction and they are directly above and B and C. So now, and if you see, just a layman can tell me that how come the AR1, AR2, they should be upward directed to react these 20 kip and 20 kip now loads which are acting in the downward direction. But intentionally, I'm now doing it in the downward direction so that you see the liberty, you see the freedom that initially you are free to assume any direction. So AR1, AR2, these are my redundant actions and directions I have selected in the downward direction. Here now you see AR1, AR2, they are unknown. Corresponding to them at B and C, we don't have any precondition. So 0 and 0. And then I'm finding out the theta, which is with the bottom horizontal card, the diagonals are making, this will become tangent inverse of 30 divided by 40, perpendicular divided by this base now, 36.86. So sine component will be coming with 0.6 and this cos component is coming with 0.8. Now vertical reaction at B and C are chosen at redundant actions. Why these are? Because it is giving you the simple simply supported structure now, which is always a basic determinate structure. Next now, this is now here the basic determinate structure is shown. Next now we go to step number 2. It is 2 degrees indeterminate. So once we will be analyzing the structure under the actual loads and it will be giving you the capital P values. Then the same basic determinate structure we will be analyzing under the application of the AR1 unit value and that will give us U1 values. And then the same basic determinate structure under the application of the redundant AR2 unit value and that will be giving us U2 values. So here now we see that the same basic determinate structure is under the actual loads 20 kips and 20 kips you see here. We take summation of MA is equal to 0. So 20 times this 40 here, this 20 we are taking. 20 times, no, this one, it is only 40. So 20 times this 40 and this plus 20 times this 40 plus 40, which is 80, minus this VD times 120 is equal to 0. So VD, this reaction at D is coming equal to 20 kips. Then summation of Fy we are going. So Va is equal to this 20 plus 20 minus this reaction 40. So 20 kip we are getting here. Summation of Fx is equal to 0. So it gives us that horizontal reaction at A is equal to, so HA is equal to 0 kips. This is not okay. This is 0 kip actually. So 0 kip we get. Now support reactions are found. Quickly we can find out the member forces now. So member forces you can quickly find out. 20, here it is in the vertical direction. 2 member forces are unknown. So a joint where at the most 2 member forces are unknown, we can apply the method of joints to find out the member forces. Quickly, how can we do it? You should take out your calculators and let's run these calculations so that you are able to quickly analyze such kind of structures. Pull out your calculators now and I'll be asking you the numbers and you should be running the numbers. Now, 20 is in the 30 feet, which is the vertical distance now. This 20 is vertical and 30. So 20 divided by 30. And we are finding out force now in the diagonal member whose length is 25 feet. How 25? No, this is not 25. This should be 50 rather. This is 30 square plus 40 square whole under the root. So 50. AF length is these diagonals lengths. Everywhere the diagonals we see, these are 50 feet long. So 20 is in the 30 feet direction, both are vertical. So 20 divided by 30, so how much force will be in the 50? So multiplied by 50, you do it. And now you tell me, CR, if you are there, you tell me how much number you are getting. Somebody should be telling me the number quickly.
Sir, 33.33.
33.33, and you see the load here, 33.33. And how we fix its direction? You see this 28 was already known that it is upward directed. So this diagonal, its vertical component should be downward directed. And when it can be downward, when this AF force, it is towards the giant. Now this is how we fix this direction. So towards the giant at A and the same towards the giant at F also. So we know the direction and we know the magnitude also of this one. Member AF, that force is analyzed. It is compression and magnitude is 33.33. Now AF, let's do something with this. AB, now AB we are discussing. AB, how we find out its direction? At this joint, if you see, this force is towards the joint A, this 33.33. So vertical component will be downward and its horizontal component will be leftward directed. Now to balance this leftward directed, we need member AB force rightward directed so that AF horizontal component can be balanced by the AB member force. So this is how it is shown rightward directed away from the giant here also. How we find out its magnitude? This 33.33 divided by 50, its length was 50. So 33.33 divided by 50 and then multiplied by how much it is going to be in 40 feet length member. So multiplied by 40. How much you get? 26.67, and you see exactly this number here. Now you ask me if you have any confusion about now fixing the direction of these member forces or the magnitude of it. So I'm not running now any sin theta and cos theta. I'm just going by the ratios now directly. And why is that? Because I need to have I will have to a lot of calculations. So I cannot go by taking joint A and summation of horizontal is equal to 0, summation of vertical is equal to 0 and spending like 2-3 minutes on a single joint now. Because it is in my mind that the same structure I'll be analyzing for U1 forces and then for U2 forces also. Okay, coming to joint B now, directly by observation again you can do it. Vertical, it is not supporting any load, so member BF load is 0. If we take again joint B for the horizontal forces, so this BA member must be balanced by BC member. So again it is. So 26.67 tensile in nature that we are showing for BC. So now within less than maybe 30 seconds, you can analyze this 1, 2, 3, 4 members. When I come to joint C now, I have 3 unknowns. So it means the method of joint is not applicable here. So what I do, I just I ignore this joint C for now and go to this D now. And already I did the same operation here for A. So again the same thing. So DE member is coming compression and it is 33.33 and DC is coming 26.6. This is done. Now you tell me when already we have this DC and CB member already in equilibrium, 26.67, 26.67. So what can be this diagonal member CF force? Obviously, it is going to be 0. Why? Because if it generates the horizontal component, how that is going to be balanced? We don't have any mechanism. So means this diagonal force we know 0. What will be the vertical? Nothing is hanging here with C now. And this diagonal is 0. So what is going to be balanced by C? Obviously 0. It is not balancing anything. So this member force is equal to 0. The top one now, it will be balancing now the horizontal component of this 33.33. So here 26.67 by this bottom mechanism already you can find out. The vertical, which was 20 here, the support reaction, which is the 4. So 33.33, this member DE vertical component will be balancing this externally applied 20, and its horizontal will be balanced by this 26.67, which is member EF force. Now, if you see, within a minute, we have analyzed this structure. That easily you can do it. And this will give you the p-values for all the members. Now, if you have noted down all these values from this sketch, we go and put this same determinant structure under the application of the AR1, which was the AR1 was the support reaction, unknown support reaction at B, and we have assumed the direction downward. So downward, we will be putting 1 kip load now and analyzing this structure. So here now you can see AR1 is equal to 1 is about the same basic determinant structure. Quickly, we find out the support reactions. So at A, 0.67 is coming, and at D, it is coming 0.33. And now, after this, what we do, we find out all the member forces. So here now, quickly, by using the same one, 0.67 divided by 30 multiplied by 50 will give you member AF. Similarly, you can find out its support, this direction also. Then we come to member AB. So you can do this one also. Here we have found out all these ones. So quickly you make a note of this one. And again, the analysis, we are going quickly by the same. If you have any problem, any confusion in this direct application, so what you can do, always you can take a joint, spend some time, and then can find out the correct value with more confidence. Quickly now you redraw this structure, and under the application of this AR1 unit value, you write the member forces quickly. Why I'm saying this? Because from here now we will be completing our member forces table. Okay, after this, now what we do, we subject this basic determinant structure under AR2. AR2 was the unknown support reaction at C, and we assumed initially this downward as our positive direction. So AR2 1 kip you see there. We analyze this structure. So here now this is coming 0.33, this is 0.67. When these support reactions are known, after this what we do, we analyze this and find out all the member forces. So here now you can note down this one, all the forces. Now, those who are completing early these entries, so what they can do, they can verify these values also meanwhile. Okay, after this now you can verify this table. AB, EAB said it is constant. AB length is 40, BC and CD, these are the bottom cards. So each one length is 40 feet. DAE looking like diagonal from here 50 feet. EF, it is the top card again 40 feet. AF diagonal 50 feet. BF 30, so it is looking the vertical member. CF again it is diagonal 50 feet, and CE it is the 30, so it is the vertical. P values capital, so for member AB it was 26.67, tensile in nature. Why? Because it is positive. BC also 26.67 and CD also 26.67. DE verify its direction now looking compression. Why? Because it is having negative sign. EF minus 26.67, it was the top coming in compression. AF was the diagonal 33.33, again it is the compression. And BF, CF, and these were 0, 0 and 0. U1 values you can verify from there under the application of unit. AR1 value and U2 value again you can verify from there. Coming to DRL1 now, combination from all the members you can see here with their appropriate sign also. You see minus minus at some location, so you need to use this with the appropriate sign. Very simple calculations, but will need a lot of efforts. So DRL1 is found, it is 5622.3 over EA. DRL2 is calculated. This should be DRL2, so here we need to make this correction. So let's make this correction. This is DRL2 now. Correction. From all the members, lengths are involved. Their P values are involved and their U2 values are involved. EA is constant. So DRL2 it is coming 5622.3. DRL1 and DRL2 values are coming the same. Next we find out F11 value. You can see the product of the values now, which one components you will multiply with their appropriate signs also. In such kind of situations, if you see minus minus and all these minus minus, it is actually square. So square of positive or square of negative is always equal to positive. So it is redundant to mention. This is just to make you understand that how from where we are getting these values. So you can directly write down 40 times 0.89 square, 40 times 0.89 squares, or you can combine them also 2 times 40 times 0.89 square. So these two are having the same values. Then 40 times 0.44 square, here 50 times minus 0.55 square, directly you can do it. And finally we get F11 is equal to 205.2 over EA. Then F12 is equal to 2, F1 is done. Here now you have the chances to get the negative values. So sometimes it is a combination of plus and minus. Here you can see minus and plus. So value is coming minus eventually. Here minus and minus will be positive. And so you need to be very specific about the sign here now. U1 and U2 are involved. F12, which is equal to F21, is coming equal to 115.8 over EA. F22 is coming now 185.39. Again, it is a square term is involved. U2 square. Always it is going to be positive. So F matrix is generated. We go to the compatibility condition now. Put all these values and find out AR1 and AR2. AR1 and AR2. So you see here, AR1 is coming 15.88 and this AR2 is coming, and you see here now here we are getting negative values. So what we do, we just reverse the directions, and these values are, now we put them here. Now being expert engineer, without any analysis, you can tell which one support is going to carry the maximum load. You see here at C, although from initial look it is looking like a symmetrical truss, but it is not symmetrical because of this diagonal member. If you throw a diagonal member here also, then it is becoming symmetrical. Now, why this B is less than the C? It is because of this diagonal member. Why? Because it is taking some load of this F vertical reaction and it is throwing it to C, and from C it is going to the support now. That is why it is about 5 kip now, taking more load as compared to this. Now, after this, you can apply this, your standard equation AM is equal to AML, AMR times AR. AML already you have the values, AMR already you have the values. So you can complete your now various columns of the matrices now. AM1 here I'm now labeling them, that my diagonal bottom, the left side is getting the priority. So AM1, AM2, AM3, then AM4, 5, 6, 7, 8, and AM9, all the 9 member forces. Accordingly, AMLs are now labeled. We have this. So AML1, it is coming 26.67, AML2 26. And this AML3 is 26.67. AML4, it is minus 33.33. So here now you see 26, 27, minus 30. And these are 0, 0, and again this one. So you should be very much now familiar with this one, how we complete the AML matrix. And next, we complete the first column of the AMR matrix, and it is coming from here where AR1 is applied, unit value of AR1. These are all those values. So AMR11, it is 0.89, then AMR21, it is 0.89, and this is 0.44. Here you can see these values. This is AMR2, second column will be completed from here, and this is what we discussed, first column, and this is the second column now. Now we complete the this AML, AMR times AR, and this is how the work is complete. Now here all the values completely analyzed structure now. Rest of the support reactions you can find out, or you can find out them by using the flexibility this matrix approach also. Now you can turn on your mics and you can ask me if you have any question.
Excuse me, sir.
Yeah.
सर अगर हम रिडंडेंट एक्शन दोनों जो है वो पिन सपोर्ट पर ले लें तो वहां से पिन सपोर्ट रिमूव हो जाएगी और सिर्फ रोलर सपोर्ट रह जाएंगे बेसिक डिटर्मिनेंट स्ट्रक्चर में तो क्या ये स्टेबल होगा मतलब ऐसे कर सकते हैं
Hold on for a second. Can you make a structure where we have both as a roller structures? As a roller supports, I mean.
मैं यही कहना चाही थी कि उसकी स्टेबिलिटी अगर इफेक्ट हो तो फिर हम नहीं ले सकते
बिल्कुल, लेकिन यहाँ पे चूंकि हमारे पास है ही नहीं ना हॉरिजेंटल लोड, तो एक्सटर्नली तो हम नहीं कर रहे हैं, तो ये इस ट्रस में आपका चल जाएगा बिल्कुल. इसमें अगर आप बी और सी पे यही रोलर आप रहने देते हैं ना, सो इट विल वर्क. ठीक है ना. हॉरिजेंटली तो एक्सटर्नली हम कोई चीज जो है ना, कोई फोर्स बैलेंस नहीं कर रहे हैं. तो यहाँ पे अगर आप कह रही है कि बी और सी पे हम लेते हैं, वी कैन स्टे विद दिस बी एंड सी वर्टिकल रिएक्शन. ठीक है, यहाँ पे आप सपोर्ट रहने दें और एंड पे क्या करें, आप रिलीज कर लें, ए और डी आप रिलीज कर लें. बिल्कुल आप एनालाइज कर सकते हैं इसको. लेकिन अगर जनरली फोर्स सिस्टम हम ले लें, ये 20 के पकड़ थोड़ा सा भी आप इसको इंक्लाइन कर ले, लेट्स से बाय 1 डिग्री, फील्ड में इस तरह परफेक्टली तो नहीं हो सकता ना कि इट विल बी परफेक्टली वर्टिकल एंड इट विल नॉट बी क्रिएटिंग एनी हॉरिजेंटल कंपोनेंट. तो इसलिए हम कह रहे हैं कि देयर शुड बी अ हॉरिजेंटल रेजिस्टिंग कैपेबिलिटी आल्सो इन केस ऑफ द ट्रसेस.
जी सही.
Any other question? अब फाइनली में भी अगर आप देख लें तो हॉरिजेंटल रिएक्शन एट ए इट इज कमिंग 0. अच्छा, इस तरह कर लेते हैं ना कि अभी इसी पॉइंट पे हम ब्रेक ले लेते हैं. आई विल बी चेकिंग बाय दिस बोर्ड ऑफ स्टडीज मीटिंग नाउ ऑनलाइन. मे बी दे आर so that I can just attend it. So you take a 20 minutes break now. It is 12 o'clock according to my this clock. So 12:20 again we are going to start now. Problem number 3. ठीक है, तो ब्रेक ले लेते हैं अब हम. Okay, now coming to problem 3. Okay, problem 3 is this one. Analyze the given truss using flexibility method and take EA. I is not involved. It should be EA is equal to constant. A, B, C the bottom joints and D, E the top joints. At D we have a horizontally applied 10 kip load. At E downward directed 20 kip load. At A we have a hinge support, and at C again we have a hinge support. So two unknowns at A, two unknowns at C, reactions are 4. So external indeterminacy, it is 4 minus 3 is equal to 1 degree. Internal indeterminacy, we have 8 members, so 8 plus 3. 8 plus 3 is 11, minus 2 times 5, 10. So we have 1 degree internally indeterminate. Total indeterminacy 2 degrees, 1 externally, 1 internally. So that's how we make this indeterminate. So here we show it. At C, we take a redundant action horizontal, we are releasing horizontal reaction. And then at member AE, we are releasing this force. So member force, unknown member force AE, we take this as our AR1, and horizontal reaction at C, we take this as AR2. AR1, AR2 are unknowns. DRS1, DRS2 corresponding. Now displacements are 0, 0. So we take them 0, 0 here. And we find out the theta also. Tangent theta is equal to 15 divided by 20 sine theta and cos theta we are finding out. This is now the basic determinate structure. Now let's go back and you draw this structure first. Problem number 3. You draw this quickly. Okay, so these are our redundant actions. AR1, AR2, you label them. And this is the basic determinant structure now. Now remember, somebody can take this vertical reaction here at C as a redundant action, BD as their redundant action. Similarly at A, horizontal and vertical there. So many options you have. Now capital P values will be generated and U1 and U2 values will be generated. So here now to generate the capital P values, we have basic determinant structure under the actually applied 10 kip horizontal and 20 kip vertical load. The structure is analyzed. We find out HA and VA and then VD. All the support reactions are known. Now we can analyze the whole structure now. So whole structure is analyzed. You see each member force here. And from here we get the capital P values. Capital P values are found. Next, corresponding to AE, which was our AR1 now, remember AE force, we applied a unit tensile force now and analyzed the whole structure. So the whole structure is analyzed here under this one hip load. Support reactions will be 0 because of the internally applied load. This is analyzed and U1 values are generated. Then corresponding to this AR2, a unit action is applied. It will straight away transfer here 1 kip. Rest of the member forces are becoming so very quickly you can analyze such kind of structure. U2 loads are generated. We complete the table. So the table is completed. Then DRL1, you see from each member the contribution. DRL2, this is again DRL2. So DRL1, DRL2 calculated. Then F11 is calculated. F12 is equal to F21 calculated, and then F22 calculated. Next, we apply the compatibility condition, and ARs are formed now. So AR1 is minus, means it is in compression, and AR2 it is not rightward directed, it is leftward directed, and we put them at their locations. You see here 9.16 compression, and this is leftward directed 17.8. AML now, AM values are calculated. So first we label the member forces AM1, 2 up to 7 members, or how many members? 8 members are there. So we label. Accordingly, we complete the AML matrix, and accordingly the AMR matrix also. Here AML is completed. Then AMR is completed. And the AMR completed matrix. Now, member interactions are found, and then we put them on here. All the support reactions and member interactions are found. Member actions, you see the member forces, and this is the completely analyzed structure. After this, now you will get this assignment 3. You will have to analyze the structure, and I'll ask Habibullah that you give 2-3 more interesting problems to them. You design them and you post for them. And already they were sending me some complaints also, maybe from section A or B, that they are not getting their recorded these lectures. Habibullah, is there any problem? Why they are not getting? Are you there, Habibullah?